Okay, today I'm going to be handling what we call sets. And this is the lesson we are going to understand how sets are experienced in our daily life and how we are going to be handling challenges concerning sets in a given exam. Please subscribe to our channel such that you get the latest videos we always upload on a daily basis. Now, when it comes to sets here, we are going to look at what a set is. And a set, we said, like we've been just studying this, and they taught us primarily that a set is a collection of items or elements, or we can say it's a collection of objects. Now, when we look at what we call the collections of items or things, there we are looking at within our daily life how sets are always experienced. Before we go any further, all of us we know those business women, business ladies, on the marketing vendors. They always organize their items like, for example, those ones who are selling groceries, those who are selling vegetables, those who are selling fruits, they always group these items in those sets. And when it comes to arranging them, here, when they organize their stalls, sometimes they arrange them basing on the say this is the set or a group of items. These are fruits, these are vegetables and other arrangements as you see them when you go to the market stalls and always you look at them. Now, when we come to what we call a set here, what we always organize, we look at a collection of items, a collection of objects, or a collection of elements. That is all about a set. Now, when you come to what we call a set, sometimes a set, we just give them, instead of writing a big statement. For example, like a set of this, a set of this, sometimes we use the symbols just to identify or to represent what we call a set. One, when we talk about the symbols we always use, when you look at the symbols we always use when we are dealing with the sets. One, when you look at their statements, we always represent using symbols. One, for example, given a set A, like when we are having this, we say given a set A here, given a set A, if at all it is written like this, say 1, 2, 3, 4. Are you seeing those ones? That is all about a set A. Now, when you look at these ones inside here, these are what we call elements of a set. And in most cases, these elements, they are the ones which are always grouped to form what we call a set. Then, things to note here when we are dealing with sets. One, the brackets. These brackets always they are very important when we are dealing with the sets. We use these curly brackets. We don't use the open. We only use, you write like the S and a 2. Then as you are closing, you write a 2 with the S. That is the way how we write these brackets which are accepted in what we call sets. These brackets, these ones are the ones which are allowed. But when you use these such brackets here in sets here, when we are representing or we are grouping, you will lose your one mark when they are marking. Also, those ones who are using these brackets, the ones which are a bit of this arrangement, those angled ones there, you will not obtain the marks. Please watch out whenever you are dealing with these numbers of sets. We always use this one. This one is wrong and this one will not be allowed. You take a note on that one. Then whenever we count these members here inside all the elements, these ones are called objects. Remember, objects or members or items or elements all together. And when we are counting these elements, in most cases, what we always do, we can count them and we say how many members here, how many elements are in set A all together. Then here, when we are representing them, we can say number, we use n, then we open the brackets. This open bracket, they are the one we are using when we are just stating the number of the members in set A. Now this one will be, now you count the members inside here, 1, 2, 3, 4, all together. Then here we say the members are 4. It means now this symbol here, in most cases, there is a statement which is behind this. This one says number of set or number of elements in set A. And in most cases, whenever we are writing this statement, like you said the number of A, it is as if instead of writing this big statement, number of elements in set A, we use this symbol and we say this is the number of elements in set A. If at all we are having another set B, you say number of elements in set B, you just note it like that. It means when we are using symbols here, we use symbols just also to represent this big statement such that mathematical identities can be always written at ease. Now, when you look at these ones, we said you have to talk about the brackets also the use of these symbols all together. Then we are having other symbols like the complement, but we shall discuss that in another video. But for this case here, what we are looking at is this one which we are going to use within this very lesson. Now, since we have seen the language or the symbols we are going to be using when we are setting out these sets, I need you just to look at, we are going to look at, when we talk about sets, we said it is just a collection of elements or members. And here we are going to look at again on what we call the types of sets. Yes, when you look at these sets, they are having types. And how many types are we having in what we call a sets? Yes, before we continue, do you know the types of sets? Okay, now there is one. The first one, we are going to have what we call an empty set. And when you look at this empty set here, we are going to look at how do we represent what we call an empty set. Then two, we are having a single tone set. Also, we are going to look at what a single tone set is all about. Then three, we are going to write to know what we call a finite set. Also, we are going to look at these finite sets, how they look like all together. That is all about finite sets. And lastly, four, we are going to look at what we call infinite what? Infinite sets. And when you look at these ones also, we are going to look at what is all about an infinite set. Please subscribe to our channel such that whenever I upload such videos, we'll be in a position to come and to learn. Now, from this point also, we are going just to look at these ones. Now, there is a UNEB trap, which always, when they are setting questions like this, they mostly set question is that when they are looking at the difference between this and this. And for information, when we talk about empty sets, yes, when we talk about empty sets, these are sets without any element or without any object or without any member within that very set. And for your information, when you are given that set A here, that set A is equal and they do like this, it means this set A has no elements. And for information here, when you say the number of those members in the set A, always they are equal to 0. Those are what we call empty sets. Are you seeing that one? And also when you look at this one, it can also be represented again by saying, if at all A they are saying is equal to this, it means when they say, when they say also that the numbers, for example, A is equal to this. This symbol also means the empty set. And the numbers of those members in set A is always 0 in what we call an empty set. As you hear the name empty, it means the members are not there. No members are there within what we call the empty set. Now, when it comes to also another arrangement here, we are having another type of which we call a singleton force. Singleton forces or singleton sets. These ones, we say these are sets with only and only one element. When there is only a single element within that very set, that set qualifies to be a singleton set. And for information, when we are having A, let us just use the color. When we are having A equals and they say the members is there is only one like that. Or when A is equal to, then they open the bracket and they say this one there is a 5. All of these ones are called singleton sets. And for information, when you learn that any arrangement where they say if at all A is given by this and there is a 0 inside here, and you see that there is a 0 inside the brackets, it means here the mem inside here over much you are seeing is 0. This is not an empty set. It is called a singleton set. And for information here, the value, the number of members within that very, or the number of elements in that very set is always 1. That is what we call a singleton set. Which means, and here that's where UNEB always tricks us. When you represent this one, and you say A is equal, when inside these brackets, and you see a 0, then you say this is an empty set because the set is 0. No, there is an element which is 0 inside the bracket. That is a singleton set. Then also we are having a finite set altogether. When we talk about a finite set here, what are we meaning? Yes. Now, a finite one, this one, a finite one, these are sets with more than one element and countable. Altogether, yes, when the number of elements inside that very set are countable and greater than 1, that set qualifies to be a finite set. Are we together? Yes, when we talk about this, for example, if at all we have element A is equal, then you have the members inside that very element, that this one is equal to 2, 4, 6, 8, 10, 11, 24, and the bracket is closed. And after that one, this one qualifies to be a finite, what we call a finite set. These sets here, the finite sets here, all members are included within that very set, and they are countable. Are we together? And they are what? They are countable. And when you look at this one, what we call the finite, always the number of those members in that very set, they are supposed to be greater than 1, and also they are supposed to be at least countable. For example, here you can take all the members, you count 1, 2, 3, 4, 5, 6, 7, and you say the members are 7. All the elements within this very set is 7. Are we together? That is all about what we call the finite, the finite sets. Then lastly, on the type of a set here, we are looking at what we call the infinite set. When it comes to what we call infinite set here, what always comes into our mind is just the opposite of this one. This is finite set. And for information, for this infinite set, it means the word infinite comes from what we call infinity. It means these are members, these are sets with elements which are uncountable. When you cannot count those members, when they are adds up to infinity. And how do we represent these ones on a set? And for example, if at all we are having set A, and they say is a set of odd numbers. Yes, when we talk about set A is a set of odd numbers, it means you can write 1, 3, then 5, 7, 9, 11, then up to infinity, because you cannot count all odd numbers and you complete them. That qualifies to be what we call an infinite set. When it comes to UNEB, I need you to know or to understand what is all about this knowledge of the types of sets and how they are applied in our daily life. My friend who is watching, please subscribe to this channel, and we are having a series of the lessons concerning sets. We are moving from simplicity to complex. It means this is the first lesson. Please subscribe to this channel, and the link for the playlist is there attached in the bio, or you are going to look at this, you look at the video, the playlist is going to be attached on every video here. This is the first video of the lessons concerning sets. Please, the playlist is there. Please don't just look at only this content and you think that the topic is over. Please subscribe, press the button for the notification. By the time we upload any video, you'll be in a position to respond and come and watch our videos. Thank you for subscription, and thank you for the time you have spent to view all of this video. Next video, we are going to look at how we are going to represent sets on Venn diagrams and other important formulas when it comes to set calculations. We meet in the next video.